Okay, I want to now talk about a situation somewhat different from the conservation of momentum for a system of isolated particles. Let's consider a similar idea. So now we have a system of particles M1, M2, M3. But in this case, they're acted on by an external force, but it's only a force in the y direction. So let's say let's say it's weight, just for example. W1 down, W2 down, and W3 down. And that is a force that's acting on this system outside the system by, for example, the mass of a planet. And so in that case, what we do is we consider the total momentum for the system, the sum of the individual momenta of each of the particles, and we take a coordinate system x and y being vertical and x being horizontal. And what we will see is that Py, big P of y is the y component of this total momentum is not conserved because it is acted on by an external force, in this case in the y direction. But the x direction has no such external force on it, so the x component of big P will be conserved. And the argument is similar to the one that we had before. We'll now take the rate of change of the x component of big P, the total momentum of the system, which is going to be the rate of change of P1x plus the rate of change of P2x plus the rate of change of P3x, which again by Newton number 2 we can say is this is the sum of the forces in the x direction on particle 1, F of 2 on 1, x component of that, F of 3 on 1, x component of that. Similarly, for each one of these three particles, Newton number 2 applied to each one. But now, again, just as I did in the original argument, I'm going to regroup these. This is 2 on 1x plus 1 on 2x. This is 3 on 1x plus 1 on 3x. And this is 2 on 3x plus 3 of 2 on x, 3 on 2 of x. And these are going to cancel in pairs, and so I'm going to get 0 plus 0 plus 0. And therefore, the rate of change of big P of x with respect to time is 0, which means that P sub x is conserved. And so the statement here is modified from the original. If a system of particles has no external forces in the x direction, the total momentum in the x direction of the system remains constant and is conserved. In the y direction, in other words, it's not conserved, but in the x direction, it is. And so this is a particular case of the previous little mini lecture where we talked about there were no external forces at all.